Yo, Algebra 2, what is up? This is Mr. Taryn, rocking with you for another video lesson. Today, in this video lesson, we're going to be looking at explicit form of sequences. The last video you watched was probably recursive, so hopefully you have that down by now. In my opinion, explicit formulas are easier and they're used quite a bit more often. So if you want to go ahead and do the warm-up, go for it. You can pause the video. I'm just going to solve it real quick for those of you who do. If you don't care about the warm-up, you can go ahead and skip past this part. But for those of you that want to do the warm-up, all we're going to do here is this is something to do with your prerequisite Canvas quizzes, substituting and stuff like that. So that's all we're going to do here. So this first one is just 2, and we're going to plug in a 12 for n. And a 12 for n over here as well. So I just basically have multiplication here. So 2 times 12 is 24. 2 times 12 is 24. 24 times 11. Let's do it on the calculator real quick. 264. So that would have been the answer for the first one. The answer for the second one is simply 3. Let's plug in an 8 up here. To the 8 minus 1, that's 3 to the 7th. You can just punch that into your calculator if you want real quickly. It should equal 2,187. You should know how to do those by now. That was a prerequisite, but why not? So let's just keep rolling. So let's keep going here. Your learning targets for this video are basically you should be able to generate some terms for a sequence that's written explicitly. And you can find any specific term. That's what this means. Find the nth term. That just means finding a specific term. So we talked about a sequence is just a pattern, right? And each number in that pattern is called a term, right? So my first term is here, my second term is here, third term, fourth term, fifth, sixth, seventh term. And so I'm going to be using that vocabulary quite a bit. Also, instead of saying, hey, let's find the 57th term, well, there's a way we can kind of write that a little bit shorter. It's this whole AN thing. That just means the nth term, the nth term. And you just put in any number you want. So if you wanted to find, say, the 57th term, it would just be A57. And it's important that you know that this 57 is the same thing as this n here because you're going to end up substituting in for n. But we'll take a look at that because we're going to do some examples real quick. So if we wanted to find the 100th term of a sequence, if we were to do this recursively, that would be extremely difficult because in order to find the 100th term, you'd have to find the 99th. In order to find the 99th, you'd have to find the 98th. In order to find the 98th, you'd have to find the 97th. And that is a waste of time, and time is cash. So we don't want to do that. We're going to think of an easier way. So if it gives us an explicit formula like this, and it's different than a recursive. Remember, in the last video, recursive formula gave you 2 parts. It gave you your first term and then a rule. This one just gives you a rule. And all you need to do is if you wanted to find the 100th term, you're just going to plug in 100 for n, both on the left side of the equation and wherever you see it in the right side of the equation, and simplify. And that's all you got to do. So this saves tons of time, and time is money. And y'all know Mr. Taryn loves money. So here we go. Find the first 5 terms of the following sequence. You're going to see a lot of this, especially coming up on a summative coming up here. So I'm just going to quickly kind of list out my 5 terms. And I want to find all 5 first terms. So for my first term, I'm going to go A1, because it's the first term, equals 1. I'm going to substitute for n times 1 plus 2. Notice I'm substituting 1 in this n, and this n, okay, because it's my first term, so my n value is 1. So let's go back. So 1 times 1 plus 2 is 3, and 1 times 3 is just 3. So my first term would be 3. Let's find my second term. All I'm going to do is I'm going to plug in a 2 for n this time. So 2 there, and 2 there for that n. So order of operations, 2 plus 2 is 4. 2 times 4 is 8. So that would be my second term. My third term is just simply putting in a 3 wherever you saw an n. 3 plus 2 here is 5. 5 times 3 is 15, so I know that's going to be my third term. My fourth term is just plugging in a 4 now wherever I see n. 4 plus 2 is 6. 6 times 4 is 24. And my fifth term, I'm just going to plug in a 5. 5 plus 2 is 7. 7 times 5 is 35. All right, and that's all there is to it. You know, just basically if it's an explicit form, you just plug in whatever term you're trying to find in for n, and that's it. Let's look at another example here. So in this case, we're asking, find a specific term. It's not asking for the first 5 terms. It wants to find the 10th term. So all we have to do is literally take our function here, our explicit formula, and plug in a 10. So 3 to the 10 minus 1. So the 10th term in this sequence would be 3 to the 9th power, because 10 minus 1 is 9. I have no idea what 3 to the 9th power is. It's going to be some huge number, but I'm doing it in my calculator real quick, and I'm getting 19683 as my answer. So all that means is the 10th term of this explicitly written sequence is 19,683. Not too bad, right? Let's do maybe one more example, and then we're going to wrap this video up. We'll probably just stop here. So for the 16th term, all I'm going to do is I'm going to plug in a 16 for n. Just like that. So I need to go 16 to the 3rd power, and then subtract 40 from that, and I'm getting an answer of 4,056. Oops, 4,056. So that's it. That's pretty much all I got here. Again, if you'd like to notice some of the other terms there are, but go for it. I mean, you could always find, say find A50 if you wanted and just plug in a 50, but it's whatever you want to do. Hopefully this should make sense. If you have any questions, make sure you reach out to your math teachers. But that's all I got. Tearing out. A whole bunch of other examples if you'd like to try.